All right. In the previous lesson, we looked at multiplying, dividing, and simplifying rational expressions. Today, we're going to look at adding and subtracting. Remember that with fractions, just in general, even if they are numbers, we can only add or subtract when we have a common denominator. So if I had something like 3 over 8 plus 2 over 8, we would get 5 over 8. With fractions, you almost want to think of it as like terms. 3x plus 2x equals 5x. So 3/8 plus 2/8. Eighths is the thing that we are counting. So we end up with a total of 5/8. The denominator stays the same. So when we look at these ones down here that are polynomial numerator and denominators that makes it a rational expression, we want to add or subtract. We already have a common denominator here. Now the main thing that you have to watch for is remember that a fraction bar automatically implies parentheses. This matters because that means we have to distribute that negative. So when I combine this, we have 5x plus 1 minus 4x minus 2. And all of that is over our common denominator of x squared minus 9. Now you could go ahead and factor that now if you wanted to. So let's distribute the negative. If I do that, I'm going to get plus negative 4x plus 2. So let's combine that down. We get x plus 3, and we can see that's a factor of x squared plus 9, or x squared minus 9 rather. So let's go ahead and factor that out. And so when this divides out, remember that anything divided by itself is 1. So we end up with 1 over x minus 3. You can't cancel out a numerator, like if you get rid of, 2 over 4, this does not equal 2. It equals 1 over 2. It's the same way with the rationals like this, okay? And then same kind of way, we would look at the pre-simplified version to figure out the excluded values here. So that would be positive 3 or negative 3 would have to be excluded. For number 12, with addition, it's much simpler because we don't have to distribute that negative. So for this one, we're just going to end up with 4x plus 5 on the top. And then remember, the denominator stays the same. So if the denominator is already the same, that makes it really easy for us. What if they don't have the same denominator? If they don't have the same denominator, then we have to find the least common multiple of each of the denominators, the LCM. That represents the common denominator. So the way we're going to do it is factor both of the denominators, and you got to make sure that you take not just one of everything, but the highest power of everything. So for example, on number 13, we are going to factor the denominators. Here we can factor out a 5x, and we get x plus 3. And here we get x plus 3 squared. So when we choose our common denominator, okay, we have a constant here, and the constant in this case is just 1. So between those, the common denominator would be 5. We have an x here. We don't have an x over here. The highest power would mean then that we need to take an x. We have an x plus 3 in both of them, but we're going to choose the higher power out of the two. And so that is going to be our least common denominator. That is what we would want. Essentially, we're trying to find something that we can force both denominators to match, okay? I think this is a little bit easier when we start working on adding and subtracting. So here's the steps we're going to follow. Find the least common denominator, and then what we need to do is multiply the numerator and denominator of each fraction by the factors of the least common denominator that are missing. We need to make them both match, so we need to build each of them up so that they match the other. In order to combine like terms, we have to multiply out the numerators, and then we can combine the like terms. If you can simplify further, then we should. And make sure you check if you were asked for the excluded values. So here we go, example 14. We're going to start by factoring this out. So I have x plus 3 over this one becomes x plus 2, x minus 1, plus, you notice I'm leaving myself a little bit of room here, 2 over x plus 1, x minus 1, okay? We need to make sure that these match. Both of them have an x minus 1 already, so that's great. The first one does not have an x plus 1, so we're going to multiply by x plus 1 over x plus 1. And now the second one will match that if it has an x plus 2. So now you can see we have x plus 2, x plus 2, x minus 1, x minus 1, x plus 1, x plus 1. They match exactly the same. Now, if one of those had been, say, x plus 1 squared, then we need to make sure that they both have a squared, so you might need to multiply by some more. So when we add this together, it's all going to be now over one common denominator. And it doesn't matter what order you put the factors in. But on the top, we have to distribute all of that out so that we can combine the like terms. So on the top, we need to multiply out x plus 3 times x plus 1. So remember, first, so x times x is x squared. Then we want outside, inside. So that's going to be 1x plus 3x. So we get 4x. And then the last is going to be 3 times 1. So that's 3. And then over here, we need to distribute the 2. So we get plus 2x plus 4. Now the bottom we're going to leave alone. You don't need to multiply it out. It's always more useful to have it in factored form, so leave it. We get x squared plus 6x plus 7. And that's all over x plus 2, x minus 1, x plus 1. So now we need to think to ourselves, does anything multiply to 7 and add to 6? No, because that 7 is positive. If it was negative, it would. But in this case, no, it does not. So that means this is as good as it's going to get, and that is our answer. So that's how we work with common denominators. This is definitely trickier. So let's look at another one. Number 15. This one has subtraction, but it's very similar. What I would like for you to do is pause your video and start by finding the factors and then see if you can decide what the common denominator needs to be. I'll pick back up here in 3 seconds. All right, this is what we get when we factor. And I would also suggest that you go ahead and switch all of these signs before you get further. That way you don't forget about distributing that negative if we just go ahead and do it now. So again, if we look at what we have, I see that the first one has an x minus 5 squared, and the second one only has an x minus 5. So I'm going to need it to be squared, so I need to multiply by another x minus 5. I also noticed that the fraction on the right has a 2 in the denominator, while this one doesn't, so I need to multiply by 2 over 2. If I do that, 2x minus 5 squared is going to be the denominator on both fractions, and so we are good to go. So 2 times x gives us 2x, and then when we distribute, again, up here, the first is going to be negative x times positive x, so that's going to be minus x squared. Outside, inside, so that's positive 5x plus positive 4x, so that's 9x. And then 4 times negative 5 gives us negative 20. All over our new common denominator, which is x minus 5 squared, 2 times x minus 5 squared. So on the top now, if we combine, we get negative x squared plus 11x, I'm getting ahead of myself, minus 20. And that's all over 2 times x minus 5 squared. Make sure that this negative is not out in front of the fraction, because that negative only belongs to the x squared, not the whole fraction. If you wanted to pull it to the front of the fraction, we would have to factor it out of everything in the numerator. So we could write negative x squared minus 11x plus 20 over 2 times x minus 5 squared. But remember, the fraction bar implies parentheses, so that negative doesn't belong to the fraction, it only belongs to the x squared. You can bring it to the front, but you have to factor it out of everything. But this answer right here would be just fine. Okay, these take some practice, especially finding the common denominator and that kind of stuff definitely takes some work. So the math lab is posted. Definitely take some time tonight to work on that. And this is something we'll continue to practice over the next few days.